Welcome to this explainer, everyone. Today, we're totally demystifying Form 2 KSM Math, specifically Chapter 7, which is all about coordinates. We're going to break down everything you need to know from calculating basic distances to finding exact midpoints, so you'll be absolutely prepared to tackle this material. Let's get right into it.
Okay, so here's our game plan for today. We've got 5 key sections to master together: the Cartesian coordinate system, distance on straight lines, slanted lines in Pythagoras, finding the exact midpoint, and finally we'll wrap up with some crucial formulas and revision tips.
Let's dive right in with Section 1, the Cartesian coordinate system. Before we do any actual calculating, it helps to understand where these coordinates even come from. This whole system allows us to pinpoint exactly where we are on a map or a graph, and it actually gets its name from this brilliant mathematician and philosopher René Descartes, historically known as Cartesius. He came up with this genius idea to mark exact locations using what we call an ordered pair. It's basically like a universal mathematical GPS. So let's establish the ground rules. The absolute center of our map is called the origin. It's perfectly located at 0, 0, and you'll often see it labeled with the letter O. From that starting point, we navigate using 2 axes. The x-axis dictates our horizontal movement, right or left. If x goes up, we move right. If it goes down, we move left. Then there's the y-axis, which controls our vertical movement, up or down. And here's the golden rule. They are always written in a very specific order. Horizontal first, then vertical. So if you see an ordered pair like 3, 5, it literally just means you move exactly 3 units to the right and 5 units up.
Let's do a quick mental check here to make sure we're on the same page. If point A is at 4, 8, we know instantly that's 4 units right and 8 units up. Easy, right? Point B is at -3, 2. So for that one, we shift 3 units to the left, but still go 2 units up. And what about point C at 6, -4? Well, that's 6 right and 4 down. Grasping this basic spatial movement is absolutely crucial for everything we're about to do next. Moving right along to Section 2, distance on straight lines. Okay, the big question here is figuring out the easiest way to measure the distance between 2 dots. When a line is perfectly horizontal or perfectly vertical, I promise you, the math is incredibly simple. You don't need any massive, complicated formula. If 2 points share the exact same y-coordinate, the line is flat. It's horizontal. You just subtract the x-coordinates, x2 minus x1. Conversely, if they share the same x-coordinate, the line goes straight up and down. Just subtract the y-coordinates, y2 minus y1. Let's walk through the math together so you can see it in action. Say we want the distance between 2, -3, and 4, -3. Notice how they both share that -3 for y? That means they're on the exact same flat plane. So we just take the x values. 4 minus 2 gives us a super simple distance of 2 units. Now what if we have points 0, 1 and 0, -2? The x is 0 for both, making it a vertical line. We take the y values and subtract. 1 minus -2. Now watch out here. Remember your integer rules. Minus a negative becomes a positive. So 1 plus 2 equals 3 units of distance.
All right, listen up, because this is a really common exam trap: graph scales. Sometimes a graph doesn't just nicely count by ones. You actually have to multiply your calculated units by the scale of the axis. So if the x-axis scale is 1 unit per box, a calculated distance of 6 is just 6 times 1, which is 6 units. Simple. But if the x-axis counts by 5s, a physical distance of 6 boxes means you have to calculate 6 times 5, giving you a true distance of 30 units. The same exact rule applies no matter what the scale is. If you're counting by 10s, 4 times 10 is 40 units. Counting by 2s, 4 times 2 is 8 units. Always check what the graph is counting by before you finalize your answer.
Now, sometimes exams love to work backwards. They'll give you the distance up front, and you have to find the missing coordinate. Don't panic, it's just basic algebra. If we know the vertical distance is 5 units and our starting y is 3, we simply set up the equation. Y minus 3 equals 5. Add 3 to both sides, and boom, our missing y is 8. The exact same logic works for the x-axis. If the horizontal distance is 4 units and we start at x equals 1, well, x minus 1 equals 4. Add 1 to both sides, and our missing x is 5. You just have to follow the logic in reverse. Up next, Section 3. Slanted lines and Pythagoras. Okay, so what happens if the line between 2 points is slanted, meaning it's not perfectly parallel to the x or y axis? Well, you actually have 2 really great tools to solve this.
Method 1 leans into geometry. You visually construct a right-angled triangle connecting the 2 points. Say the horizontal base is 6 units and the vertical height is 4 units. Using Pythagoras' theorem, the slanted line, which is our hypotenuse, squared is equal to 4 squared plus 6 squared. That's 16 plus 36, which gets us 52. Take the square root of 52 and you're looking at exactly 7.21 units. Now, method 2 skips the drawing entirely and just uses the distance formula. You subtract the x's and square them. You subtract the y's and square them. Add them up, take the square root. 5 minus 1 squared is 16. 1 minus 7 squared is negative 6 squared, which is 36. Add them to get 52, and the square root brings us right back to 7.21 units. So you see, whichever method you prefer, the math holds perfectly true.
That brings us to section 4, finding the exact midpoint.
So what actually is a midpoint? Honestly, conceptually, it is exactly what it sounds like. It's a specific point that divides a straight line segment perfectly, equally in half. Think of it as the absolute center between two locations on our grid. For the visual learners out there, you can actually find this without any major math equations. If you have a slanted line AB, imagine that right triangle again. First, find the middle of the horizontal base and the middle of the vertical height. Next, construct perpendicular bisectors. Just draw lines straight up and straight across. Right where those two lines cross, that exact intersection is your midpoint. In this specific geometric setup, our point P sits perfectly at the coordinates 3, 4.
But hey, if you don't really want to spend time drawing bisecting lines all over your graph, math gives us a wonderfully simple shortcut, the midpoint formula. Now, it might look a little complex with those small numbers, but guys, you are literally just finding the average. You add the two x coordinates together and divide by 2. Then you add the two y coordinates together and divide by 2. That's really it. Average the x's, average the y's, and you're done.
Let's actually put that formula to work. Say we want the exact center between point M at 10, 7 and point N at 4, 1. First, isolate your pairs. 10 and 4 are our x's, 7 and 1 are our y's. Now just plug them into that averaging formula. 10 plus 4 is 14, 7 plus 1 is 8. Divide both of those by 2, and we end up with 7, 4. See? As long as you take it one step at a time and stay organized, you really can't get it wrong.
And finally, section 5, formulas and revision tips. If you take absolutely nothing else away from this explainer today, it should be these two golden formulas right here. These are the tools that completely unlock Chapter 7. Honestly, I'd highly recommend pausing the explainer right now and grabbing a screenshot of this for your final exam revision. For distance on a slanted line, just remember the square root formula, which, like we saw, is really just Pythagoras in disguise. And for the midpoint, remember you're simply finding the average. Add the x's and divide by 2, then add the y's and divide by 2.
We started this whole explainer talking about René Descartes, right? The mathematician who looked at a totally blank map and figured out a way to pinpoint any exact location in the world, just by using two numbers, an ordered pair of x and y. Well, you now have that exact same logical power. You can calculate distances, find exact centers, and navigate this entire system with total confidence. So my question for you to ponder today is this. If simple coordinates can give us perfect direction on a blank map, how will you use this kind of structured, mathematical logic to navigate your own future? Thank you so much for learning with me today, and definitely keep conquering those math problems.